All right, guys, let's go ahead and get started for today. So like I said, we're going to be working out of day 20's material. So let me go ahead and share my screen so we're all on the same page. There we go. Okay, so if you go to classwork, underneath the videos, day 20, go ahead and click on Weathering and Erosion Notes. Go ahead and open the guided notes right to the right. Okay, so share the PowerPoint now. There we go. All right, so today we're going to be talking about two processes that happen to the rocks that we have been talking about when they are at or near the Earth's surface. So we talked about the three types of rock: igneous, sedimentary, and metamorphic. And we talked a little bit about weathering and erosion when we talked about the formation of sedimentary rocks. Because remember, weathering and erosion creates sediment that then can be compacted and cemented together in order to form sedimentary rock. But in this case, we're going to focus more on what is that process, what's going on to the rock to cause it to weather and erode. How are those, two processes involved in shaping the surface of the Earth? And in that, we're also going to take a look at like the age of rivers, because the age of a river can really be determined by how much it has eroded, weathered, and changed the landscape that it goes through. So we're going to take a look at how those processes take out over time. All right, but first let's talk about weathering. All right, first off, what is weathering? Ooh, okay, there's sound effects. I don't know if you guys hear those or not. All right, what is weathering? Well, weathering is the breakdown of rock at or near the Earth's surface, okay? So we're talking about the breakdown of rock. So it's gonna start off as that solid piece as either sedimentary, igneous, or metamorphic, but something's gonna happen to it to cause it to break down. And some of these changes can happen quickly and some take a much, much longer time. It really depends on what process is causing the rock to weather and also where that rock is located. So we're going to see that temperature can also play a role, right? Colder areas, things don't move as fast, things don't interact as fast. Warmer weather, they do. So we're going to see some differences in between where the rocks are in terms of climate as well. Now, of weathering, there are two different types of weathering. There is mechanical, this is sometimes referred to as physical weathering, and then there is chemical, okay? And they're quite different in how they affect the change in the rock. So mechanical or physical and chemical. So taking a look at mechanical weathering, this is when a rock is broken down into smaller pieces without changing the chemical properties of the rock. That is so important. You're basically just making it smaller, but it's still the same type of rock. If it was sedimentary, it's going to continue to be sedimentary. It's just smaller pieces of sedimentary rock. If it's igneous rock, it's going to continue to be igneous rock. Again, it's just going to be smaller pieces. So like taking a hammer to something and smashing it up into a bunch of pieces changes the overall shape, but it doesn't change the chemical makeup. That rock still contains its properties. This can be caused by a number of different things. Freeze thawing, which we'll get into in a second, it's called ice wedging, the growth of plants, as well as the actions of animals and humans. So plants, the roots grow into cracks, then they get larger, widen those cracks, give them more space, they can eventually split rocks. Animals and things like that that dig through the ground also do the same thing. They abrade, there can be abrasion occurring to the rock where they dig by it or something like that, and little bits of that rock is actually going to fall off. And then there's also us, right? We plow through the sides of mountains instead of driving over them. So we do this a lot. When you're making a road, instead of going over that hill, you can just kind of cut through it. And you guys see this a lot when you travel around on highways and stuff. If there's some actual topography, Indiana's pretty flat. So maybe this isn't the best example, best state to give an example of seeing cutting through the land like that. But anytime we build a house or something like that, a lot of times we dig down, we set the foundation and stuff like that. So we really do change the surface of the Earth as well a lot. So we could also be considered agents of weathering. All right, so one of the mechanical types of weathering, like I said, is freeze thawing. We know that water expands when it freezes. So what happens is water can get down into a crack in a rock. The temperature drops. That causes the water to take up more space. It expands. This is also why you can't put glass bottles in the freezer, because they will break, they will shatter as that liquid expands, as it freezes. So the same idea happens to these rocks. And you can see in the picture, the laser pointer so you can see where I'm pointing. You can see in the picture what this freeze thawing has done to this boulder. It can start off as a very, very, very small crack in the boulder, but over a very long time, it gets down in the crack, it freezes, expands, that makes the crack wider. Then the water thaws, right, turns back into a liquid. So what does it do? It seeps deeper into that crack. Well, when it freezes again, it's pushing on the sides as well, makes the crack wider, and this process repeats itself and repeats itself and repeats itself. So the expanding water is what actually cracks apart the rock. As it turns into ice and expands, it physically pushes it. Now, is that rock the same? Yes, 100%. This piece of this rock will chemically match this piece of rock because they came from the same piece, but they're just now, or the same chunk, they're just now in smaller pieces. So this is the true idea of mechanical weathering, breaking it down, making it smaller, but not changing the makeup of the rock. And sometimes this is referred to as ice wedging, because it's almost like, driving a wedge through something. Any questions about this? All right, I'll assume that's a no, so we'll keep moving. Was that a question? Or someone's mic? All right. Plant growth. We talked about this a little bit. The roots of trees can enter the cracks of rocks, and the same idea. They start off real small, they get into that crack, but then as the tree grows older, those roots get wider, and it can actually break into the rock and cause it to split further. So again, not changing the physical or the chemical makeup of the rock, just changing the shape and size, breaking it down. All right, next we have abrasion. Okay, abrasion is actually the grinding away of rock by other pieces of rock. So this doesn't happen so much here in Indiana, but think about out west in the desert, and you can kind of see this in the picture. As the wind blows, it picks up sand and dust, and that sand and dust run into other pieces of rock. And what happens is when they hit, they actually do make a little scrape. They scrape away at it, almost like sandpaper. So what can actually happen is when you see abrasion, the bottom of the rocks might get real narrow while the top of the rock stays larger. And you guys have seen these, stones that just barely look like they're sitting upright. And it's because abrasion has caused the bottom to be rubbed away, okay, broken down. So abrasion, as the wind moves, picks up little bits of rock and pebbles and sand, and that eats away at the bottom or the sides of the rock. All right, so those were all mechanical. Those were all physical weathering. Now, that's not the only thing that can happen to the rocks. Some rocks can go through chemical weathering. Chemical weathering is the breakdown of rock through chemical changes. The key here is the chemical makeup of the rock is not going to be the same from the start to the end of this process. Now, that can be caused by different things. It can be obviously caused by water, oxygen, carbon dioxide, living organisms like lichens, we'll take a look at those in a little bit, as well as acid rain. This is one where we're going to see a difference in climate. So for example, chemical weathering occurs more rapidly in warmer, wet climates. So if it's warm and humid a lot of the year, you're going to see a lot more chemical weathering because those reactions happen or they occur faster with the higher temperature. So if you think about somewhere like, I don't know, tropical rainforest or something like that, you might see more chemical weathering because warm weather, lots of precipitation, right? And that's a good combination to see lots of chemical weathering. So here's a picture of lichens. What we need to understand is, we don't talk about a ton in this class, but life started off in the ocean and later expanded to land. And one of the ways it achieved that, one of the ways it terraformed the land, were the lichens. Okay, lichens were little, algae fungus combinations, and you can see the picture here. And they come in all different colors and shapes and whatnot. But what they do is they can actually grow on the side of rocks. Now, why is that important? Well, because at one point in time, the surface of the earth was nothing but rock, right? All the land mass, there was no grass, there was no dirt. Those take thousands of years dirt takes thousands and thousands of years to actually accumulate and eventually be, habitable for plants and things like that. So lichens were one of the first organisms to colonize bare rock. And what happens is, like I said, they're a little fungus and an algae. What you can see on the outside is the fungus, and on the inside it contains the algae. And the fungus provides the algae with a water source, because it can keep water in that, inside that little fungus body. And it provides it shelter, somewhere to live. The algae does photosynthesis. So it takes in water and carbon dioxide and sunlight, and it produces food in the form of sugar and oxygen. So what the fungus gets out of this relationship is the algae provides food for the fungus. So we call this a mutualistic relationship. It's actually two species existing together. And what's really cool is these lichens will grow on the rocks, and they physically, chemically break down the rock. I shouldn't say physically, they chemically break down the rock. That they secrete different enzymes and byproducts from the life processes that physically eat away at the rock. And it's going to chemically change the rock. The rock is not going to be the same underneath the lichen than it was before. Then the lichens eventually die, and their biomass is just left there. And eventually that can build up, and the little bits of broken down, chemically weathered rock, in addition to all the biomass from the lichens, is eventually the precursor to soil. So once that happens for thousands and thousands of years, then you get a little bit of buildup there, and then you can see first grasses and things like that, maybe mosses, but then grasses and stuff like that. Eventually those grasses grow, they die, they add their nutrients to the beginnings of soil, and eventually you get bushes and then the trees, and that's the process of succession. But that doesn't happen without the lichens starting that process. So lichens are really, really cool organisms working together. Okay, so like I said, a chemical weathering causes the rock to experience a chemical change. Its makeup is not going to be the same as it was at the start. Water, we call water the universal solvent. That's because if you give water enough time, it breaks down most substances. Even the biggest mountain ranges in the world eventually get broken down by things like water and some of these other processes we've been talking about. But water will dissolve things most of the time. Oxygen causes something called oxidation. Oxidation best as rust, but technically it's only called rust when it is the oxidation of iron. So you can have aluminum oxidize as well. It doesn't turn red, it doesn't look like rust, but again, it gives it kind of like a white chalky substance where the oxygen is physically interacting with the surface of whatever it's acting upon, whatever it's changing, and that with either the aluminum or in this case the iron is going to result in some kind of oxide, some kind of oxidation, some kind of little residue. Acid rain you probably heard about. Acid rain is also an agent of chemical change. The acid in acid rain is very diluted. It comes from all the pollution and stuff that we put in the air. The water evaporates, just the water evaporates, it gets up, it's clean when it's just forming in clouds and stuff like that. And then as it moves through the air and it falls, it runs into a lot of that pollution and stuff like that, like sulfuric acid. So what happens is it builds up, but it's very, very diluted. So it does get into the rainwater, but it's diluted. The problem is then the rainwater eventually will evaporate. The issue that it leaves behind is it leaves behind whatever the acid is, right? Only the water evaporates. Everything else that was in the water stays where the water evaporated. So the acid can eventually build up to levels where it does start reacting with things like marble and limestone. So if you look at those, ancient Greek statues and stuff like that have been left out in the, outside in the rain a lot, you can see all these kinds of holes and whatnot in them because the marble's eaten it away. I think we have a picture. Yeah, here we have a picture. Okay, so here's one of those statues, and if you zoom in, this is what it looks like at the surface. It looks like an acid has eaten away at that because that's really what's happening. It rains, the rain gets on the statue, the rain water evaporates, but anything that was holding stays, eventually builds up and can eat away. And then here's some oxidation. We see lots of oxidation out west. That's why there's a lot of iron in the rock and whatnot. And so we can see that reddish tint to some of those rocks. That's oxygen acting with the metal ores in the rock. Also living organisms, so roots produce weak acids as well that can dissolve rock. So living organisms, in addition to the lichens and stuff like that, though, that's where they're talking about with the breakdown, chemical change of rocks. Okay, so once those materials have been broken down, either by chemical or physical means, they can then be moved from one place to another by natural forces. This is erosion, okay? Erosion is the movement of sediments that broken down material from one place to another. So, anytime we do any kind of construction, we have to be very concerned about erosion because as it rains on that construction site and all that ground is exposed, that water is going to pick up little bits of sand and silt and dust and whatnot, and it's going to take it somewhere else, and you can get lots of problems occurring. So that's why a lot of times in construction sites around the edges, you might see some like plastic liners or something like that in the ground so that it limits the amount of erosion that takes place. So there are 4 main agents of erosion. Some people will say 3, and I'll explain why some say 3 and some say 4. But water is the biggest agent of erosion. Rain, streams, rivers, waves, oceans, all that movement of water, groundwater as well, all that movement of water is constantly causing erosion to occur, taking sediment from one place to another. Think about when it rains. When it rains a lot and you drive by a stream or something like that, what color is this stream? Well, it's a real brown color after a storm. Why is it brown? Because it's picked up all that mud and dirt. That's erosion taking place. It's picked up all that sediment as it travels over the land and it collects in the rivers and streams. So that's why they'll look real brown and murky and dark because it's picked up all that sediment. Now, eventually, once the water's calm, that sediment falls out, right? And the water starts to get clear again. But the key is as it's moving across the land, it picks up a lot of dirt, dust, and whatnot. That is erosion in place. Sometimes people include ice with water because yes, ice is technically just a solid form of water. But when we're talking about ice, I want you to understand we're talking about things like glaciers. As glaciers move over the landscape, at the bottom, they are grinding the crap out of the ground and the bedrock. So what happens is they churn up and they crush and they pulverize lots of rock into some fine sediments as they move across the landscape. This area wasn't affected as much by the glaciers from the last ice age, but a lot of the glaciers kind of came down and melted and formed a lot of the water for the Great Lakes. And you can see where those glaciers moved and carved out, pathways as they moved across the landscape. So they very, very much are a big agent of erosion as well. Wind, things like dust storms and sandstorms, those are giant examples of wind erosion. We also talked about wind moving sediment with abrasion, right? Moving that sand, those pebbles. Any movement of sediment is erosion. So wind definitely picks up that dust and can move it from one place to another. And last but not least, we have gravity. Gravity is a constant force, but gravity often causes things to fall. And so we can get things like landslides or mudslides or avalanches. Well, guess what? That is moving bits of sediment from one place to another. So again, this is another agent of erosion. As that, landslide, as all that ground and mud and whatever comes down the side of a hill, it's moving that sediment from one place to another. So it is an agent of erosion. So again, sediment is just that material that gets moved. Okay, sediment is small solid particles of rocks or other organisms. It can be living things, like here we see seashells and feathers and whatnot that will eventually become sediment, or is considered sediment now. But also little smaller pieces like the sand itself. That's also sediment. Sand, dust, clay, silt, all that stuff that's easily moved. Small rocks, pebbles. All right, well, if that stuff is going to be moved, eventually it gets dropped somewhere, right? Eventually it stops moving and it settles out somewhere. That is deposition. So the reason we say erosion and deposition in the same breath a lot of the time is because as that material gets moved through erosion from one place to another, it's eventually deposited or dropped in its new area, its new position, okay? Depositions can obviously create new landforms like beaches and sand dunes. An interesting thing about deserts and sand dunes is they're constantly changing. The wind constantly changes the location of the dunes themselves. So that's why there can be places like in Egypt where, we search the desert for these ancient tombs and Egyptian, pharaohs left behind from earlier times. Well, sometimes the dunes are in an area and it's completely covered and no one ever sees it. And then eventually it might get uncovered by a sandstorm or something like that. But these dunes, if you time lapse it, you can actually see them move from place to place. They migrate, which is really cool. A beach is a giant example of a deposition. None of that, broken down seashell and sand and other stuff, none of that started on the beach. That was brought to the beach by the waves, the tides, and the water. So eventually that builds up over time. So beaches are a great example of deposition at work. All right, so now, like I said, we're going to focus on one of the most effective agents of erosion, and that is water. The reason water has such a profound effect on the surface of the planet is because of the water cycle. The sun heats the water, causes it to evaporate. That causes it to rise up in the air, move somewhere else, cool, eventually condense into clouds and maybe rain, and then fall into some type of precipitation, whether it's rain, sleet, snow, hail, I don't know. But the water falls out, gets into the ground, hits the groundwater, eventually makes its way out to the ocean, and the cycle repeats itself. Because of that constant cycling, because of that constant evaporating, raining, water has the biggest effect on the surface of the earth. And water collects in rivers and streams. So let's talk about how we determine how old a river or stream is. Well, let's talk about a young river. A young river is identified by a very, very steep slope and very, very fast velocity. That's the speed of the water. So if we see in this picture, you see that very, very steep slope, right? The river's at the very, very base of this, and there's not a lot of space. There's not a very big valley here. It's just where two mountains are kind of coming together, and there's a little bit of a low point. That's what creates the stream. What's going to happen is over time, this is going to erode away this area. And it's going to cause it to deepen. So that valley is actually going to get deeper and deeper over time because of the fast moving water is eroding away the sides of the mountains that it's touching. The shape of the valley tends to be very straight. If you notice, there's not a lot of big curves. Yeah, there's some small curves in that water, but I'm talking about big curves. We'll talk about those. Those are called meanders. But it's pretty much a straight line. If I look at this picture, I could kind of make a best fit line like you do in math sometimes, right? Just moving up and down right here, we see there's not much change in the path of that river or stream. Another thing is the valley is V-shaped. So again, like I said, there's not flat areas on either side. It just kind of comes down and the lowest point is where the water is. So what kind of special features are we going to see? We're going to see lots of waterfalls, lots of rapids, maybe some islands. But the key is we're not going to see any tributaries. Okay, we're not going to see anywhere where water's kind of collecting or spreading out or anything like that. It's just going to be this very narrow, fast-moving stream. Now, what is erosion going to do to this as time passes, as it gets older? Well, as a river ages, some very key things happen. Okay. First off, that steep slope is going to become less steep. Why is it less steep? Because the sides of the mountain are getting eroded, right? The whole mountain itself is constantly under the pressures of erosion. So eventually what's going to happen is it's going to get more flat. That's going to cause the speed of the stream or river to slow down. It's not as fast moving anymore. It's not changing elevation as much. So the water's going to slow down. You're going to see a wider valley, right? So look, over here, you can see the two sides of the valley. It has really gotten wider. Now, this is obviously not the same one, but this is a more mature river. And this one started off just like that other one did, that V-shaped valley. But now we've got this flat area in the middle, right, where all this weathered material has really built up over time. The river is going to start to meander. So this is that word I was using earlier. You see these bigger bends. Those are meanders as it goes back and forth and back and forth. Those bigger curves are called meanders. Some key features of a mature river is that the channel touches both valley walls on the meanders. So boom, I've touched this mountain, then it goes over here, boom, it touches that mountain, then it comes back. So what's happening is the stream is kind of zigzagging between the two mountains that it exists between. So it touches both valley walls. And again, the valley is wide and flat. That's lots of sediment built up over a long period of time, flattening out that area. So what other features might we see in this type of mature river? You might see an oxbow lake. What that means is, let's say it rains a whole bunch and this river floods. What might happen is the water might be moving so fast that it kind of creates a new channel to connect these two, right? It would be a more straight connection and it would cut off one of the meanders. If one of the meanders gets cut off from the main stream during a flood, it becomes what we call an oxbow lake. It's just kind of this body of water that's kind of a U-shaped, but it's not flowing. It's not part of the main stream anymore because as that floods, it may connect other parts of the stream and it may find a new path. You can obviously see that when it rains a lot, it might flood in the bottom of this valley. So we might get a floodplain. And we might start to see some tributaries, some areas where some things, branch out, flatten out. We get some collection of water there. Then we get to an old river, okay? What does an old river look like? Well, an old river is nearly flat. Look at this land. I don't see mountains anywhere in sight, and that's because they've been completely eroded away, completely pulverized by the agents of erosion, and now we have an almost flat area. The water is going to be moving very, very slowly. It's very sluggish. Okay, again, there's not a lot of change in elevation, so this water is very, very slowly moving down this stream. We can see that there's almost no erosion taking place, so this isn't really widening anymore because, again, of the slow moving water. And it's very meandering. Look at how wide these things are, right? Look, this comes in, goes all the way across, then turns and comes all the way back. Huge, huge, huge meanders. And this just, again, changes over time, all right? It gets wider, meanders more. Another key characteristic is it does not touch the valley walls. We can't see the valley walls anymore because it's so wide and so flat. There's obviously going to be lots of flooding in this area. Many oxbow lakes. So again, if let's say a flood occurred and it cut off this little piece here, this whole section right here would become an oxbow lake. If for some reason the water pushed through and just connected this little sliver of land right here, the river might take a new path and cut off one of those meanders. We might see some swamps or bayous in this area, again, because it's so flat and it's so inundated with water. We might see some bogs or swamps or bayous. So again, what are the key features as a river ages? Well, it starts off very narrow, very fast moving, and it's very steep. And what happens? Well, it slows and it gets wider and flatter. And then it slows and even more, it gets even wider and even flatter. So those are the keys that happen to a river as it passes through and gets older. Okay, did you guys have any questions before we finish up the notes?
No, I'm good.
Okay. Sydney, you're good? I don't see a mic for you, so I don't know if your computer has a mic or not. But you can definitely type in the chat if you have a question. Okay. All right. Last but not least, if you go ahead and go back to the Google Classroom, let me share that part of my screen again. So now what you guys are going to do is you're going to open up erosion and deposition. Okay, and this is going to continue talking about erosion, the different agents of erosion and deposition. So kind of, again, focused on rivers, because again, these are the best examples of erosion and deposition constantly happening to reshape the surface of the earth. So it's just a little article that has little reading checks along the way. So you got this section, you got a little reading check. You got this section about water, and then you got some questions to analyze and answer. I don't know why it's not showing you more space, but there is lots of space here for you to write, so please don't skip over that. That page is not that small. I don't know why the page lines are showing the way that they are. But again, you're going to be analyzing the maps. Guys, these are contour maps. These are a lot like the isobar maps. So if the lines are close together, you see how close together these lines are? That means it's very, very steep. You see how these are further apart? It's less steep. Do you see how you don't even see very many lines in this one? It's almost flat. So again, that's how you read these topographic maps. The closer the lines are, the steeper the elevation is, the further apart they are, the flatter it is. All right, you can skip number 3. It doesn't format correctly. This is just a check for erosion or deposition or both. If you want to answer it, you can, but if you want to skip it, I'm okay with that because the formatting didn't come out correctly. Part 2 is on wind. So remember, wind is another agent of erosion. So we're going to talk about that a little bit. And then the last part is on gravity, the third agent of erosion. So they're not so much focused on ice and glaciers here, but they are focused on the 3 main agents of erosion, water, wind, and gravity. So you guys read through that, get those questions answered, and then submit that back to me. And then all you have after that is the exit ticket right here. All right, what questions do you guys have for me?
I'm all good on questions.
Okay. Well, if you guys don't have any questions, feel free to go ahead and get started on that article. Like I said, when you get done, go ahead and submit that back to me and do the exit ticket. And that's all that we have for class for today. So I'm going to hop off the Zoom, but reach out if anything comes up. But otherwise, good luck. Okay? All right, guys. Thank you for zooming in today.